Hello, welcome to the Motion Graphs lecture. Make sure you have a paper and pencil in front of you. You take this very seriously. If you don't understand something that was said, rewind it, see if you can get it. If not, write down the question and make sure you see me in class. Any notes written from this lecture will be considered extra credit. You show me the next day and I'll give you the credit. Let's begin with a distance versus time graph, where we discover in a distance versus time graph, we discover velocity. Well, how do you discover velocity in a distance time graph? Well, it's actually very simple, and that is that the slope of any line on a distance time graph is going to be the velocity, because the slope of a line is change of y over change of x. And for instance, 0 to 5, it's going to be 10 divided by 5 is 2. And it'll be plus 2 because it's in the plus orientation. So it's going to be 10 over 5 is plus 2. Let's see how that matches up relative to looking at the equation. Here's the equation. The slope m equals change of y over change of x, which is change of d over change of t, and that's going to equal the velocity. I'm taking my time trying to explain some of what's going on here in the first few slides, and then what we'll do is we'll go through the next batch rather expeditiously. So you can see the first one is plus 2. It's plus 2 because that the change of y is 10. 0 to 10 is 10. And the change of x, 0 to 5, is 5. So it's going to be 10 divided by 5, which is 2. Easy? So let's go through the next bunch very simply and very quickly. Okay? We can clearly see that the next slope is 0. Any horizontal line, the slope is 0. I'm giving myself 12.5 seconds to answer each slide. Let's see if we can do the next one. So the change of y is 10 to 30, which is 20. And then it goes from 6, 7, 8 to 12. Okay, so on the x-axis, then again that's plus 5. So then you have 0, then plus 10. So make sure you can get these. Make sure that it's simply the change of y over the change of x. The next one you can see is going to be 0. Okay, so that's easy. Let's do the next one. The next one is going to be 1, 2, 3. That's right. That's 30 divided by 3 is 10. Why is it negative 10? Why is that negative 10? It's interesting. Well, it's negative 10 because it's a negative slope. You can see quite clearly that that's a negative slope. And then try to do the next one. Okay, so you can get that, and that's also negative 10. And that's really it for that graph for velocities. We're going to look at other things in a moment. So we're going to discover acceleration, which relative to graphical analysis is the slope of the line of a velocity time graph. So we're going to get to do that in a moment. I've given myself a few extra seconds for each slide. Here we see the slope of the first line is going to be plus 2, then 0 is going to be the next one. Then the slope of the next line is going to go from 8 to 12, which is 4. And then 10, then 20. So that would be 20 over 4, which is 5 plus 5. All right, so it's going to start to go very quickly. Make sure that you can find the slope of each line as we do it. +2. All right, then it looks like it's going to come up to be 0. And what else do we have? Here comes 0. Okay, that's 0. Now, the next slide is going to be, what did we say it was? It's going to be 20 over 4, which is +5. All right, then obviously 0. You see that I actually use the same graph for the distance time, so those slopes are going to be very similar. We're also going to look at things like average velocities. You know, what's the average velocity in each segment? You know, just the segments, beginning and final. You know, the initial and final velocities. Again, go very slowly. Make sure you can get these even before we get to them. Try to predict what they're going to be. Okay, let's see. Coming up. Very curious. And it is, yes, it is 0. Now the next one, we didn't really get a chance to do some of these, but you see it's going to go, y is going to go from 60 to 30, so that's 30, and then 1, 2, 3, so 30 divided by 3 in the negative direction is going to be -10, then 0, and then it's going to go, 26 to 29, which is 3, and then 30 to 0, so that'll be -10 as well after the 0. Make sure that each slide, you know, each addition, each slope, you can do yourself. Make sure there's no hesitation with your ability to do that. We see that the last one is going to be -10, coming up in right now, and that's it. That's all she wrote. Okay, now we're going to try a little different thing here when it comes to the slope of lines and velocity and average velocity, etc. Okay, next we're going to try to discover what the average velocity is. Average velocity of a line segment or any segment in the graph would be either the total distance divided by the total time, or in this case, when we look at individual segments, it's going to be the initial velocity plus the final velocity divided by 2. There it is right there. That's the equation. So for instance, the first segment would go 0, which is the initial. You have 10, which is the final. So final plus initial. So 10 plus 0 divided by 2 would be +5. Now, all of the velocities in the first quadrant. This is the first quadrant, quadrant 1, and they're all going to be positive. So let's get started. First one is +5. The next one is going to be 10, because you're going to say 10 plus 10 divided by 2 is 10. Okay, so now, and remember, they're all positive here. We're not talking about slopes. We're talking about the initial velocity plus the final velocity divided by 2. So you can see the next one is going to be 30. That's the average there. The next one's going to be 30 plus 60. That is 90 divided by 2, which is +45. And the next one should be also +45. That's going to be the average velocity of the two. Okay. Oh, sorry. The 60 plus 60. That's the horizontal area there is 60. Then +45. Then we're going to get +30. And then it's going to be 30 plus 0 divided by 2. Okay. And that'll do it. All right. the next one, and make sure that you can get the average velocity in this manner. The average velocity in this manner. Okay, we'll try the next one. Okay, total distance. Total distance is going to be the area underneath the graph segment. For instance, in this particular case, if you say area, the area would be velocity times time, because that's going to be the area. For instance, the first segment, it would be a triangle, which would be 1/2 the base times the height. The base is time, the height is velocity, velocity times time is distance. So when you look at the equations that you're doing, for instance, right here, it would be 1/2 of 5 times 10, which is 25. So the first segment would be 25 meters, right? Easy. So then you put in the 25, and you keep track of the total distance. So the total distance so far in the first segment is going to be 25. Now, the next segment is we'll try to do maybe another, maybe a big triangle here, a rectangle. I'm sorry, and the rectangle is going to be length times width. That's how you find the area of a rectangle. Well, the length is going to be time, and the height is going to be velocity. So that's going to be 210 meters. Okay, 210 meters. Because you have 21 times 10. So then you keep track of it. Now you have 235. So you go from 235 and then do another segment. You have this one is 45, little triangle. See, this is the thing. You have to do these triangles so that you clear out the odd curve, so that you're just left with regular sections that you could fill out for a rectangle, that sort of thing. So make sure that each of these calculations make sense to you. And again, we're keeping track of, we're up to 320 meters total distance. Right? There's 280, that segment is 280. Now we're up to 600. Now you can see that the top section is made of 3 parts. It's made of the left triangle, a right triangle, and then in the middle there is a rectangle. So what do we do for that? What do we do? Well, what we're going to have to do is we're going to have to put them in and do the area 1/2 the base times the height, and that's what we're started to do. So both of those are the same. It's going to be 1/2 3 times 30, it's 45. And now the last part you can do yourself. 1, 2, 2 on the time, and then 30 on the top. So 2 times 30 is 60. So that would be 750, and then you're done. Easy. So that's how you do it. That's the area under the curve, which is distance traveled. Now again, another way to get it is to simply multiply velocity times time. Same thing, same idea. All is exactly the same. Okay? So that is total distance traveled, the distance under the curve, multiplying the base times the height, or 1/2 the base times the height. All right, here we go. We're going to do a different kind of exercise here. We have 4 graphs. That was A. This is B. A was a distance time graph. B is a velocity versus time graph. And then C is going to be a distance versus time graph. And then D is going to be a velocity time graph. So what we're going to do is, this is what we're going to do. We're going to do A and C first, and then we'll do B and D next. So here's A, distance versus time. Okay, this is A, distance versus time. And then we're going to look at C, distance versus time. Okay, so we're going to do the questions for the distance time graph first, and then we'll look at the velocity time graphs. Okay, the first one says, what is the displacement during the first 4 seconds? Now this is for graph A and C. What is the displacement during the first 4 seconds? Well, you can see here in the first 4 seconds, you're going to go from 10 to 20, so your displacement is plus 10. Remember that, plus 10. The next one, you're going from 0 to 4. You're going from 0 to 20, so it's going to be plus 20. So here you have plus 10 and plus 20 as the answers to the first question for A and C. The next problem says, what is the displacement between 4 and 6 seconds? Remember, when they say displacement, what they're really meaning is, what's the distance traveled? So, now, you can see that when it goes from 0 to 4 seconds, it's going forward. And from 4 to 6 seconds, it's going backwards. So the question is, how much is it going? It's going from 20 to 10, backwards. And this one is going from 20 to 10, backwards. So therefore, it would be negative 10 in both cases. Negative 10 in both cases. Now, remember that this is directional. It's actually a vector, and you can see that it's negative 10 and negative 10. The next one is very similar, and it says, what is the displacement between 6 and 9 seconds? Between 6 and 9 seconds. And if you look at the graph between 6 and 9, you see that in graph A that there's actually no displacement whatsoever. So therefore, what's happening? The person is actually, or the vehicle is actually standing still. The person is actually standing still. True for graph C. There's no displacement. So what's going on? There's only one answer. They're standing still. Remember, the slanted lines, if you look at the slope, they're the velocities. So here we see that both answers are 0, meaning 0 displacement, meaning that the individual or the vehicle involved was not moving. Next, what is the velocity during the first 4 seconds? What is the velocity during the first 4 seconds? Well, you can see here that I've written it in. I've actually done the calculation. And it's going to be the change in y over the change of x. So it's going to go from 10 to 20, and then from 0 to 4. So it'd be plus 2.5. The next one, same idea. It's going to be, in this case though, the distance traveled is 20 meters, and the time is 4 seconds. Therefore, it'll be plus 5 meters per second. Plus 5 meters per second. And if you look at the answers, that's exactly what I have here. Plus 2.5 meters per second, plus 5 meters per second. Next, what is the velocity between 6 and 9 seconds? What is the velocity between 6 and 9 seconds? Again, we're going to look at the slope. And here we see that it's a horizontal line, so there is no slope. So again, we said that the person's not moving. Well, if the person's not moving, their velocity or speed is 0. So in this case, if the person's not moving, their velocity is 0. Same thing true for graph C. They're not moving, so their velocity is 0. Simple enough. Now, next, we're going to look at the answer, and then we're going to actually see that this particular sheet is done. So it says, what is the velocity between 6 and 9 seconds? The answer is 0, 0 for both graph A and C, relative to the velocity between 6 and 9 seconds. Now, let's look at the graphs again momentarily. This is graph B, which is velocity versus time. And we're going to be working with graph B and graph C for this next set of questions. The graphs are, as you see, velocity versus time instead of distance versus time. So here's the velocity versus time graph. So we're going to ask a series of questions that you should actually have already tried because you have these worksheets. And we're going to see if we can answer these questions. Now, don't forget that the slope of the line is going to be the acceleration, and the average velocity for the first quadrant are all positive. First question is, what is the average velocity of the object in the first 5 seconds? What is the average velocity in the first 5 seconds? Well, I've done it out here for you. You can see for the first 5 seconds, it goes from 0 to 40. 40 plus 0 divided by 2 is 20 meters per second. Remember, all average velocities in this quadrant are positive. This is another way to do average velocity. And the next one, you're going from 10 to 20, so that's a change of velocity of 10 over 5 seconds. So that would be 20 plus 10, and then divided by 2 is 15 meters per second. Next, so those are the answers, plus 20 and plus 15. Now, what is the distance traveled by the object in the first 5 seconds? Now, this is interesting. We know that the distance traveled is going to be the area under the curve. The distance traveled is the area under the curve, and it's for the first 5 seconds. So, it's going to be a triangle, and it's going to be 1/2 the base, which is 5 seconds, times the height, which is 40. So 5 times 40 is 200. 1/2 of that is going to be 100 meters. So you see that the area under that curve, we call a curve, can be not a curve. A curve can be a straight line. When we say the line under the curve, the area under the curve, we just simply mean the area under the plotted graph. For the next one, we see that it's going to go from 0 to 5, and you're going to have a rectangle as well as a triangle. So it's going to be, the rectangle is going to be 25 meters, and the triangle is going to be 25 meters, and the rectangle is going to be 50 meters, and that gives a total distance of 75 meters. Again, under the curve. Even though the curve doesn't go down to 0, it starts at 10, it's irrelevant. Again, listen carefully. It's the area underneath the graph, underneath the plotted line. So you see the two answers are 100 meters and 75 meters. Those are the distances traveled to the area under. Now, area under the curve. What is the acceleration of the object in the first 5 seconds? Now, remember what acceleration is. Acceleration is change in velocity over change in time. So this would be 40 over 5 would be 8, and it's positive, so it would be 8. It would be 8 meters per second squared, and it's positive. Don't forget to put in the positive sign. I neglected to put that positive sign. Yes, the positive sign is understood. I understand that. But just for emphasis, it is a great idea. Take it from me, take the advice, and always put the sign in. Next, it's going to go from 10 to 20, so that's 10, that's the difference, and it's going to be over 5 seconds. So it'll be 10 divided by 5 plus 2, and you can see how it's a flatter rise, so it's not going to be as great of a slope. And so that's going to be plus 2 meters per second squared. So the answers are plus 8 and plus 2 meters per second squared. Plus 2 and plus 8 meters per second squared are the slopes of the lines, slopes of the curve for those particular ones. So it's going to be, notice how I wrote in the plus 8 meters per second squared and plus 2 meters per second squared. Next, we're going to go back to average velocity. What is the average velocity between 5 and 9 seconds? What is the average velocity between 5 and 9 seconds? So it starts out with 40, it ends with 20, so it's going to be 40 plus 20 divided by 2 would be 30. Again, it would be plus 30, that's the average velocity. Don't think of negative slope, it's only negative slope if you're talking about acceleration. So the average velocity is 30 plus 30 meters per second. Notice here, I learned my lesson, I changed my ways, and I put in the plus sign. Okay, put in the plus sign. Again, always very important to put in the direction of the vector. Here, we start with 20, we end with 20. 20 plus 20 is 40, divided by 2 is 20. Very simple. So the average velocity for this particular graph is going to be 20 meters per second. And we will show that in the answer sheet coming up in a second. Okay, now we're going to do the area underneath this curve as well. Here we have plus 30 meters per second and plus 20 meters per second. What is the distance traveled by the object between 5 and 9 seconds? And we're going to see that it is going to be the area under the curve. Now, did you notice that was horizontal? So it's just going to be a square for graph D. For graph B, it's a little bit more complicated. You're going to have a triangle and a square. You're going to have a triangle and a square. So you can see that the triangle is 40 meters, okay, and it's 1/2 the base times the height, so it'd be 1/2 of 4 times 20 is going to be 40, and then the length times the width is going to be 4 times 20. And this one, you can see that it's going to be the area under the curve is going to be simply a rectangle. We see that it's 5 to 6 is 1, to 7 to 8 to 9 is 4 seconds. 4 times 20 would be 80. So you can just by inspection see that that's 80. Length times width. Length times width. So let's take a break here for a moment and I'll be right back, and you'll see that the answers are in the table. Why don't we do that first, and then we'll look at the next problem, and we'll see that it's 120 meters and 80 meters, that's correct. And then what is the acceleration of the object between 5 and 9 seconds? So we're going to look at the graph. We're going to be looking at the slope of those graphs. Okay, so here we see it's going to go from 40 to 20 meters per second. It's going to decelerate over the course of 4 seconds. It's going to go from 40 to 20. So 20 divided by 4 is 5, so it'll be a -5 meters per second squared, and that's exactly what is shown here. Notice the negative. The negative means that it's a deceleration, so you can say that, you can say one of two ways. You can say it's a negative acceleration is the same as saying a deceleration, same exact thing. The next one, you can see that there is a constant velocity. There is a constant velocity. Therefore, the acceleration is 0. It is a constant velocity. Remember, an acceleration is a change in velocity. If it's constant, then the acceleration is going to be 0. So it'll be -5 for graph B and 0 for graph D. Now, make sure you understand the three things. The distance, the area under the curve, the average velocity, and the acceleration is the slope of the line. Here I have -5 meters per second squared and 0. Now, at what points is the object stopped? At what points or point is the object stopped? In other words, it's not moving. Well, in the first case, it's in graph B, we can see that it's obviously at 0 meters per second squared. It's not moving because it's 0, so it's stopped. There's no velocity at all at that point, 0. And then it's at rest at no time for graph D. It's at rest for no time at graph D. All right? So that's going to conclude this particular worksheet. Then we're going to go on to a more challenging set of worksheets. Okay? We're going to actually continue with this, but it's going to be a little bit more complicated. So it's going to be 0 and none is the answer to number 7. I'm going to take a break. Again, sorry, I'll be right back. You'll never know I was gone. All right, let's go to the next one. A little bit more unusual question. During what time periods is the object slowing down? Well, we see that in a velocity time graph, it would be where it's decelerating. So we can see very clearly that what the time intervals are here. There are 2 time intervals for graph B, 1 time interval for graph D. You just look at the beginning points and end points on the x-axis, and that's going to be the answer to the question. So there are 2 different areas on B, 5 to 9 and 16 to 25. Even though there was 2 different slopes, it's still slowing down, but at a different rate on that. And then we see that the average velocity is going to be 20. We're moving more quickly through this. Here it's going to be plus 25. I left the slowing down label there. My apologies. So we see that it's going to be plus 20 meters per second. What is the acceleration between 9 and 12 seconds? And that's going to be the next one. And then we see that the slopes are 0 for graph B between 9 and 12 seconds. And then for graph D between 9 and 12, it's going to be a plus 3.3 meters per second squared. We're moving much more quickly. I think I said that it was more complicated, but it's actually very similar. What is the distance traveled by the object between 9 and 12 seconds? The first one is going to be pretty straightforward. It's just just a rectangle, and that's 60 meters, because that would be 3 times 20, velocity times time, 60 meters. The next one would be a little bit more complicated because you have a triangle there. So that's 15 plus 60 is 75 meters, would be the total distance traveled. Again, remember, it's going to be velocity times time. Velocity times time is going to be the equation for that. And then what is the acceleration of the object between 20 and 25 seconds? What is the average velocity, the average acceleration, sorry? That's -8 meters per second squared for that time interval. And you see that there's 2 different accelerations, even though it's slowing down. Plus 4 meters per second squared. And then, what else? Then That's going to be plus 4 meters per second squared. So that's going to be negative 8 meters per second squared and plus 4 meters per second squared. Easy, pretty easy. And then this is going to be plus 55 meters per second. That's going to be the average velocity there. And then the average velocity on the other same time interval will be plus 40 meters per second. Again, don't let the negative slope throw you. They're not asking you for a slope. They're just asking you for an average. What is the average velocity of the object between 12 and 16 seconds for both? And so it's going to be, again, 40 meters per second would be the average. And then for graph D, it would be 45 meters per second squared, because it's going to be 30 plus 60 is 90 divided by 2. That'll be plus 45 meters per second squared. And then what is the distance traveled by the object between 20 and 25 seconds for each graph? Very simple. 100 meters is the triangular part and 50 meters is the rectangular part. So that's 150 meters, and then 150 meters for that one as well. Okay, same. Okay, that's that part of it, and there's the end of it. 150 meters for each one, and that finishes lecture number 7. And again, re-watch it if you have to. Make sure that you study. The notes that you take can be used on your test if they're directly from the lectures. Have a nice day.